Here we're going to be finding the integral of x squared minus 1 over the square root of 2x minus 1. Now I'm going to break this up into two separate problems. In the first integral here, we're going to be using u-substitution. Well, we're going to be using u-substitution in the second one also, but the first one's going to be the tricky one. So I've broken it up into two separate integrals, and we're going to be solving this one first. So as usual, what's in the radical or in parentheses, we let be the u, and then I take the derivative and I get 2 dx. Well, we have a dx up here, but we don't have a 2. But I guess I better look at this first. We need to go ahead and solve for x in this equation here, so we can go back and substitute this x squared in. And so I throw the 2 out front because we've got the 2 dx, but I must put a 1/2 out front here. I meant to say a 2 inside and 1/2 out front. Now we're going to do the substitution. So we had the x squared, and remember x was equal to u plus 1 over 2, and we plugged in a u plus 1 over 2, so that leaves us with the square root of u in the bottom. I guess I should mention something here. I could have just went ahead and just, because the 2x minus 1 was equal to u, and I could have just went ahead and substituted this whole piece and just put a u in here. I don't know why I did that, but it works out anyway. I multiplied this out up here. This is squared. If you square the 2, you get a 4th, and I went ahead and brought the 1/4 out, and then ended up bringing it way out front. And 1/4 times 1/2 is 1/8. Now the next order is we go ahead and multiply this out. This is u plus 1 squared, so that would, once you pull that out, expand it, I guess I should say, we end up with this. And of course I got it out of radical form and put it in exponential form here, and then I'm going to break this up into 3 separate fractions and then take the u to the top. Alright, and then I simplify this all down. I get u to the 3/2, 2 times u to the 1/2, and u to the negative 1/2. Then I go ahead and take the integral, and adding 1 to each one of the exponents, right? You should know this by now. Simplifying this, flipping that, 2/5, right? 2/3, and 2. I go ahead and write this 1 here. It's not necessary, but you can see that I flipped it. And let's see. I think I just rewrote everything. Multiply 2 times 2/3 here. Drop that 1. Factored out a u. Always factor the term with the smallest exponent out, and I did. Now I want to get this into one single fraction, so I need to get a common denominator, and that's what I'm doing here, getting a common denominator. And I factored out a 1 over 15, and then I think I'm going to end up factoring, let's see, a 2 out of here, and I do that. 15 times 8 is 120. Alright, so this simplifies down to 160. Then I go back. I've simplified this down as far as I can, and remember what u was equal to. In the beginning it was 2x minus 1, so I plug in the 2x minus 1 where there's a u. And now what we want to do here is simplify this down. So I go down through here and simplify it down, as you can see, collecting like terms here in this step. Got this back into radical form and rewrote the final answer. Now that was the first part. So second part here, as you can see, this is just a simple u-substitution problem. Right, so I get down here, take the integral of it, remember to substitute back in. Now it's time to put them both together, And I have, and as you can